Hi, my name is Linton, and we are from the Oxford Robotic Institute in University of Oxford. Here we're presenting a multi-camera visual inertia odometry pipeline, and that's the hardware here where we were also doing a live demo for the last hour. So the idea here is by using multiple cameras, fuse them together, we should get a more robust system and have more accurate state estimation as well, especially in this sort of a very challenging environment.
Is it 4 cameras?
Yes, exactly, 4 cameras.
Okay.
But with more camera you add in, we propose the general framework that you can add as many cameras as you want. But then, of course, the problem comes, the computation becomes the constraint.
Yeah.
So we also further propose 2 other novel methods to address this issue. One of them is to tracking features from one camera to another. So you're passing on the information to another one to reduce this sort of the new features being detected. And the second part is doing sort of feature selection. So you don't have to actually optimize all the features. You need to select what's the most informative one and then use that into your optimization backend. So that would speed up the system.
Yeah. So is this actually writing the videos to disk as well, and doing anything with the data, or is just the features you're extracting?
So here we are doing it live. So we're not writing anything down to the disk. We can if you like.
Yeah.
But it's doing a live tracking. So if let's say I move it here, you can see that I rotate it around. You can see the post inside the viewer, right? So if I do some rotation, you can see that, right? Left and right.
Yeah.
And now if I cover, let's see, these cameras, it still works. If I cover the one on the right, you can see my hand. I do some rotation. It should still be fine.
So there's some redundancy.
Exactly, the redundancy, robustness, and accuracy comes in this little package here.
Here at ICRA, we're presenting some of our research platforms, in particular Tiago, which is one of our most popular platforms for research into mobile manipulation. And also we're presenting prototypes of the Kangaroo platform, which is our new generation of biped.
Yeah. So, and then what's the reasoning behind there only being one arm on Tiago?
So with Tiago, it's short for take it and go. So it's a robot where we want to provide modularity. So the idea is that the researchers can build their own Tiago, meaning that we have different models for bases. We have a base that is differential, another base that is holonomic. They can choose between having one arm, 2 arms, a hand, a gripper, different end effectors. But the idea is to provide this easy configuration for researchers to have the platform that they need and not adapt their research to the platforms that they got somehow on the lab.
So they would give you their requirements and say like, hey, we want 2 arms, we want this type of a base that you guys would build in, or they have the flexibility of...
Yeah, we have already built everything. So there's like a configurator, and we help them choose the best options. So which kind of model they want, which kind of configuration they want of the Tiago. And then we deliver the platform that they have built. So if they want a platform with 2 arms and a holonomic base, we have those components, and we just put them together into a platform that is fully working on ROS, fully integrated, so no more hassles about having to spend the time of the PhDs trying to figure out how to make the robot work.
Yeah, and so what areas of research do you most see people using this?
So it's been used for a lot of different kinds of research. So a lot of people are using them for advanced manufacturing topics, factories of the future. Other teams are using them for healthcare applications, helping older adults. Other research teams are using it for cybersecurity, for test technologies like 5G into robotics. We have even teams that are doing research into ethics with the robot. So basically there's a lot of variety of fields, including also human-robot interaction. So basically we want to provide a platform that is easy enough for people to use.
Yeah.
And it's also quite popular for competition. So we've also seen a lot of teams using it for demonstrating their research, demonstrating their what they have been able to do during competitions like RoboCup at home or the European Robotic League.
Yeah. And so also there's this gripper at the end.
Yeah.
Is that something that can also be swapped out with different types?
Yeah, definitely. So we offer several types of grippers, some that are our own grippers and some that are third party. That we have already done the electromechanical integration, so it's a seamless integration where in less than 5 minutes the user can swap the end effector.
So
Today I want to show the demo of active auto rotation. Active means by using small motor, we can increase the rotational speed. It is a kind of active auto rotor. So our target is inspection, underground mall or underground subway. So micro UAV is a very sufficient tool, efficient tool for the inspection, but it often has a problem. It has some collision. After that, it falling down and break.
Yeah.
So we want to prevent such kind of situation.
Oh, so this is like a protective casing.
Yeah, that's right. But the protective case is not sufficient because when we falling down, the protective case and the UAV often breaks.
Yeah.
But if we put such kind of active auto rotation, we can drastically reduce the impact force as a
Did you
result.
say it was active rotor rotation?
Active auto rotation.
Okay.
Active means the use of active motor. So we call the active auto rotation.
What's an active motor?
Active motor is such kind of motor, powered motor.
Oh, got it.
Yeah.
Okay.
Because usually in helicopter, everyone use a passive joint.
Yeah, just like roller bearing or
Yeah, that's
something
right.
like that.
That's right. Of course, if we use a passive joint, we can generate a sufficient reduction of velocity.
Yeah.
However, in the underground mode, height is very limited, 5 or 10 meters. So we want to increase the more reduction force. So we add the active rotor.